Students, let's discuss this case study, which says that a coach is training three players. He observes that player A can hit a target 4 times in 5 shots. So if we consider A, B, C event, we can consider A, B, C event. So where A says that player A hit the shot, player A hit a target, okay. And similarly B event we can consider player B hit a target, and C event will be C hit the target. So here it's clearly mentioned, then out of 5, 4 times he get the shot. So probability of A we can say it's 4 by 5. Player B can hit 3 times in 4 shots. So out of 4, 3 times he can hit a target, 3 by 4. Where player C can hit 2 times in a 3 shot. So player of C can hit 2 by 3. So these are the 3 probabilities. Now I will check the question. Let the target hit by A, that already we have supposed here, isn't it? B be the event that target is hit by B, and C be the target is hit by C. I think this should come here. Okay. A be the target by A, like we considered here, no, this way. Then the probability that A, B and C all will hit. So probability of A hits the target and B hits the target and C hits the target. Okay, when 2 cases will be there, we say both should happen. So we take intersection, isn't it? So now all 3 should happen. All 3 should hit the target. So that means intersection of all 3. Since it is independent event, because uh, hitting of the player A, target hitting of player A is not getting affected by the player B and C. Okay. So we can use this formula, P of A into P of B into P of C. So 4 by 5, 3 by 4 and 2 by 3. You will observe the cancellations here. 4 will get cancelled, 3 will get cancelled. Final answer for the first question will be 2 by 5. Okay. Now next question. First of all, let me write all the probabilities here once again. P of A is 4 by 5 we know. P of B is 3 by 4 and P of C is 2 by 3. Now let's check the question. Question 2 referring to 1. What is the probability that B, C will hit and A will lose? So we in probability, in terms of probability, how can we say B hits the target and C hits the target but not A. A will lose means A will not hit, isn't it? So again we can use the concept of independent event. Probability of C into probability of A complement. So B will be 3 by 4, C will be 2 by 3, and from here P of A is 4 by 5, so 1 by 5 we can write. Cancellation we can observe. So final answer will be 1 by 10. Now let's check the third question. With reference to the event mentioned, what is the probability that any two of A, B and C will hit? See, any two means 3 cases will arise here. Probability of any two means what? It is not mentioned that which two. So we can have A and B hit the target but not C. Or second case, whenever cases will be there, we will add all cases, isn't it? And by equivalent statement also you should know, or means plus. So B and C hits the target but not A. Or the third case will be B, A and C will hit the target but not B. Okay, any two can be either A or B, B or C and A or C. So now each one we can use the independent event formula. P of C dash plus P of B into P of C into P of A dash plus P of A into P of C into P of B dash. Okay. Now substitute all the probabilities. 4 by 5, 3 by 4. C dash means 1 by 3 plus 3 by 4, 2 by 3. A dash means 1 by 5, 4 by 5, 2 by 3. So it will be 1 by 4. Now cancellation will be there. I think 4, 3, 3 cancel. Here we will get 1 by 5. Here 3 cancel. 2 we can cancel. 1 by 10 we will get, because this is same as the second part. See. Then here 4 cancel. 2 by 15 we will get. So I think we can go with the 30, LCM 30. So 6 plus 3 plus 2. 2 is already there, plus 4 divided by 30. So 13 by 30 will be the answer. Okay, 13 by 30 will be the probability of any two of A, B and C will hit the target. Question number 4. Question number 4 says, what is the probability that none of them will hit the target? None of them will hit the target. None of them will hit the target means not by A and not by B and not by C. So we can write P of not A and not B and not C. So this we can get by A complement into P of B complement into P of C complement. So this will be 1 by 5. For P of B was 3 by 4. So it will be 1 by 4. And this will be 1 by 3. So final answer will be 1 by 60. Now what is the probability that at least one of A, B or C will hit the target? See, actually when we say, these are all the elementary event if we consider. P of 0, 0 means no one hits the target. Okay. Plus P of 1 means anyone hit the target, anyone. So in any one, 3 cases will arise. A will hit but B and C will not hit. B will hit but A and C will not hit. C will hit but A and B. Any P of 2 means any 2. So here 3 probabilities, here 1 probability. Okay. P of 2 means any 2 will hit. So any 2 we can use the question number 3 answer. Or P of 3 means all will hit. All will hit. All these probabilities will give sum up to 1. Now we should find at least one of A, B or C will hit. At least one means one or more. Okay. So for 1, 3 cases we have to add. For 2, 3 cases we have to add. For 3, 1 cases we have to add. Instead of doing that, what we will do, this refers to at least one will hit the target. We will find 1 minus P of 0 means no one hits the target. Okay, so probability of at least one will be 1 minus probability of none, which we know already from question number 4. 1 by 60. So final answer will be 59 by 60. Okay. So that's all about this case study. I hope you understood. Thank you.